Hello and welcome. Now that you have a basic understanding of Excel and its features, let's get started with one of the most versatile and powerful components in Excel, functions. Imagine that you have been given some Excel workbooks that contain sales and financial reports, and you have been asked to analyze the data to assess the performance of the company and its employees. Well, Microsoft Excel has some incredible features that will make these tasks a lot easier than they may initially sound. Excel's vast catalogue of pre-built functions are there to serve almost every purpose you could possibly need to achieve when constructing formula to calculate, compare, analyze, organize, arrange and display various kinds of data. You will discover that the more you are able to understand and work with functions, the better you will become at using Microsoft Excel. In this module, you'll explore what makes a function, how they're comprised, why they're useful, and where they can be used. And you'll identify different methods for constructing formulas and inserting functions in a worksheet before you start applying them in a practical way. You'll discover the difference between sorting and filtering and how both of these features can be applied to organize and arrange how data is displayed. You'll see how sorting can be used to arrange data in an order such as alphabetical, and filtering can be used to refine the data by criteria. You'll learn what cell and range names are, why they are useful, and how to add, edit and delete them in an Excel worksheet. Before looking at how to use cell and range names in formulas, you will discover that Excel also has a wide range of specialized functions that can be used to perform complex operations on data for a variety of different purposes, and explore some of the specialized function categories, the syntax that defines them, and how they can be applied to manipulate and control data. You'll learn how to use text functions with various operations to manage, refine and extract text data, including functions that enable you to trim, join and transpose text values in a worksheet, as well as change the case of text. Finally, you'll explore how to use logical functions that apply conditional logic to produce a true or false result that can be used to analyze and organize data, and examine the main logical functions and, or and if, and how they can be used with data. By the end of this module, you'll be able to work with formulas and functions, sort and filter data, apply a range to data, use specialized functions, use text functions, and use logical functions. Learning these core skills and applying and using functions will create strong foundations for the rest of your learning journey in Microsoft Excel. Have you ever had difficulty using formulas and functions in Microsoft Excel? I know I have. Thomas Bradshaw from Westcal Publishing has to start using Excel for reporting, invoicing, ordering and timesheet keeping as he trains to become an account manager. In order to do this, Thomas needs to learn how to use formulas and functions. One of the most powerful features in Excel is the ability to perform real-time calculations on data within workbooks. Using these powerful features will enable Thomas to save time and reduce errors when trying to calculate complex or simple equations. Formulas are mathematical expressions that calculate the value of cell contents. When cells contain numerical data, you can perform multiple mathematical operations on the cell content. The results of these operations will be shown in the cell that contains the formula. Formulas can be simple, such as adding two cell values, or quite complex, involving multiple mathematical operations. Let's take a look at the formula bar. You can start by opening the Westcal Publishing Sales Report document. Firstly, a function is a predefined formula and a quick way to enter certain calculations. For example, the sum function creates a formula that adds blocks of numbers. There are many functions built into Excel, and you'll explore more of them in another lesson. The FX button on the left side of the formula bar opens the Insert Function dialog box. However, typing a formula into a cell or into the formula bar just below the ribbon is the most straightforward method of inserting basic Excel formulas. The process always starts by typing an equal sign, followed by the name of an Excel function, a calculation, a value, or a cell reference. You can tell if a cell contains a formula by clicking it to make it the active cell. If there is a formula in the active cell, it will be shown in the formula bar. Here, the sum function is being used to add data from cells C2 through to F2. Now let's take a look at some of the important elements that make up an Excel formula. You may have noticed that formulas always begin with an equal sign. You could read it as the number in the cell as a result of the equation. Formulas can contain cell references such as A1, numbers such as 23, or functions such as sum, open parentheses, B2 colon B9, close parentheses. And what that says to Excel is get the sum of everything from B2 to B9. Cell references are not case sensitive. These are all examples of valid formulas. You can enter a formula by typing directly into a cell or into the formula bar. If you include a cell reference in a formula, such as B3 multiplied by 6, and that cell reference itself contains a second formula, such as B1 plus B2, stored in B3, that second formula B1 plus B2 will be evaluated first, and the result will be used in B3 multiplied by 6. Let's look at some examples of the symbols that are used in formulas to tell Excel what mathematical action to perform. Here you have a list of 8 operators listed from top to bottom in order of precedence. Operators are symbols that represent specific mathematical operations, including the plus sign, minus sign, division sign, and multiplication sign. Operators specify the type of calculation that you want to perform on parts of a formula. When you create a formula with several operators, Excel evaluates and performs the calculations in a specific order. For instance, Excel always performs multiplication before addition. This order is called the order of operator precedence. This means that in Excel, some mathematical symbols are considered to have a higher priority than others, and this influences how Excel processes a calculation. The table on screen shows that the operators listed from top to bottom in order of precedence. So Excel does not simply calculate expressions from left to right. Certain operations are performed before others. If a formula read B1 plus C5 minus D10, that would be processed left to right. But if a formula read B1 plus C5 multiplied by D10, the multiplication would be done first and then the addition. You can see how that might produce a result that you didn't intend. You now know that Excel follows certain rules of precedence. Multiplication and division have higher priority than any other mathematical operator. But it's important to understand that they have equal priority to each other. For example, in the formula B1 multiplied by C5 divided by D10, Excel simply works from left to right. Addition and subtraction are next in overall priority, but again have equal precedence calculated from left to right. Greater than, less than have equal precedence calculated from left to right, but lowest priority overall. So how can you be confident that Excel is processing your formula in the right order? You can impose your own order of operations by enclosing expressions in parentheses. The operations inside the parentheses will be evaluated before the operations outside. Putting part of the formula in parentheses indicates to Excel to do this part of the calculation first. If you have parentheses within parentheses, the expression in the inner parentheses will be evaluated first, and the result will be used to evaluate the expression in the outer parentheses. One easy way to remember precedence order is to remember the word BEDMAS, which stands for brackets or parentheses, exponents, division, multiplication, addition, and subtraction. As you've seen, cell references are included in formulas using the column first and row number format. If the same formula needs to be included on every row of a block of data, Excel speeds up the process for you by allowing you to create the formula in one cell and copy it into other cells underneath. This is a huge time saver. But what happens to the cell references when Excel copies the formula? Cell references are naturally relative references, which simply means that if a formula is moved or copied to another location, Excel will change the references relative to its new location. For example, the formula C1 plus D5 copied down a row would become C2 plus D6. In a situation where you need the same formula to be repeated in every row of a block of data and still work correctly in each row, this is incredibly useful as it means that you can copy the formula to save time. But what about a situation where you don't want one of the references to be adjusted when you move or copy the formula? You can prevent the adjustment by changing the reference from relative to absolute. Absolute references use $signs before the cell or row to make sure a formula always references the same location, no matter where the formula is copied or moved to. You can assign absolute cell references in 3 ways. $column $row. Both the row and column reference will not change. $column row. The column reference will not change, but the row can. Column $row. The row reference will not change, but the column can. As you can see, a $sign simply fixes part of a cell reference. Now that you have an understanding of what formulas and functions are and the main components involved, let's have a look at how to use functions in a practical way in Excel. The purpose of a function is to provide you with an easy way to perform a complex calculation so that you can focus on results instead of trying to remember your grade school math equations. Let's explore how to make the best of the functions provided in Excel. Functions are pre-made operations that are used to perform calculations. Excel features a few functions related to basic math, financial applications, logic, date and time, and more. Every function formula will automatically have the function word followed by parentheses. Inside the parentheses will be the arguments. Arguments define the data to calculate, such as a value, a cell reference, or any input that can be used in a calculation. You may notice that inside the parentheses, the arguments are separated from each other by punctuation marks, such as commas or semicolons. Together, functions and arguments comprise a formula. Let's have a look at some methods for creating formulas in an Excel worksheet. You can start by adding a column of 10 numbers. To create a formula using the numbers in these 10 cells, you could type equals A1 plus A2 plus A3 through to A10. However, this would quickly become tedious and would also make the spreadsheet harder to work with. A much more efficient way of performing this calculation is to use the sum function, followed by selecting the range of cells you want to add to your formula. This is much easier than typing out a very long formula and allows for more flexibility if you need to include additional rows within the formula range. You can create the same function using autocomplete. As you are typing into the formula bar, Excel will suggest functions and show a description of the top result. You can use your arrow keys to select the desired function and press Tab to apply it, or continue typing and ignore Excel's suggestions. Once the function is entered, Excel will prompt you to enter each argument as necessary. For the sum function, the arguments will be the values and/or cells to be added. It is good to remember that you can click and drag to add cell ranges to the formula. When the formula is complete, add the closing parentheses, press Enter, and Excel will calculate the value. So far, you have used the sum function, which is quite easy to remember. Now let's try out the Insert Function dialog box to create functions. Thomas from Westcal Publishing needs to calculate the average amount of sales revenue made by each representative of the sales team over the past 4 quarters of the financial year. You could use functions to achieve this. Let's have a look at how to do this. Open the Westcal Publishing Sales Report document. You can start by first selecting the cell into which you want to insert the function, then click the Insert Function button on the formula bar, or click the Formulas tab and then Insert Function. The Insert Function dialog box will open. At the top, you can choose a category. Selecting a function in the Select a Function dialog box will display a description of the function and the required arguments. Choose the desired function from the list and click OK to insert it. The Function Arguments dialog box will appear. Here you can select the cells containing the arguments for the function. In many cases, Excel will predict the arguments based on the position of the function and automatically enter them in one or more of the argument fields. Required arguments will be indicated in bold and optional arguments will be indicated in plain type. Selecting one of the argument fields will display a description and the constraints of that argument. If required, complete the arguments by selecting the argument field, then selecting the appropriate cell or range of cells to complete the function. Then click OK. You can also insert common formulas using the AutoSum command on the Home tab. First, click the cell immediately below the data if using AutoSum on a column, or to the immediate right of the data if using AutoSum on a row you want to calculate. Then click the AutoSum command to use that function, or click the drop-down arrow to choose a different one. The function and the arguments will be inserted based on the surrounding data. As well, the column or row of data to be summed will be highlighted. Press Enter to complete the formula. Let's take a quick look at the functions available in the AutoSum menu. Sum adds values in a specified range. Average determines the average value in a range. Count numbers determines the number of cells that contain a numeric value in a range. Max finds the highest value in a range, and min finds the lowest value in a range. You can view AutoSum calculations in the status bar. When you select a range of data, Excel will automatically calculate the average, count, and sum of the data and display it in the status bar. To view additional automatic calculations, right-click anywhere on the status bar to display the Customize Status Bar dialog box, where you can click to select or deselect from the available options. By default, Excel will automatically calculate formula results. However, this process can be delayed depending on the size of the workbook. To force Excel to calculate the workbook, click the Formulas tab and then Calculate Now. The calculations will then be completed, although you will not receive a notification when the process finishes. Have you ever wondered what the difference is between sorting and filtering in Excel? Suppose you have a long list of records including dates, products, sales figures, customer names, and more. You can quickly organize the data to display the results that you need using Excel's sort and filter features. Thomas at Westcal Publishing has been asked to find a way to display only the sales results from representatives in a certain region in the company sales report. Thomas knows that Excel has two features, sort and filter, that allow you to change the display of data or refine the data shown. Thomas needs to gain a better understanding of the differences between sorting and filtering so that he can use the appropriate tool to display the specific data required. Let's take a look at the main differences between the two commands and how to use each feature. Sorting allows you to change the order of data. Text-based and numerical data can be sorted in ascending or descending order. When dates are typed correctly, they are recognized as numbers in Excel and can also then be sorted by date order. It's important to keep in mind that when you sort data, you're not changing the data in the worksheet, you're only changing how it is displayed. Additionally, while there is no option to clear a sort and return it back to its normal state, the undo command has the same effect. Finally, data will be saved in the order you sorted it in. This means that if you need to undo a sort, you can only do it in the same session as when the sort was applied. Let's have a look at how to do this by sorting data in Excel. You can start by arranging the data in alphabetical order by the region column. Right now, it is in random order. To do this, we will select the column header and click the Sort A to Z command in the Sort and Filter group of the Data tab. In this case, Excel notices that there is data in the surrounding columns that is likely related to the column you want to sort. When this happens, the Sort Warning dialog box will open and ask if you want to expand the selection or continue with the current selection. Selecting Continue with the current selection will only sort the data in column C, leaving the data in the other columns unchanged. This will result in the data becoming misaligned and inaccurate. Select Expand the selection and click Sort to correctly sort the data in all of the columns. For more options and control in sorting your data, you can click the Data tab and then Sort to open the Sort dialog box. Where your data contains column headers or titles, you can select the My Data Has Headers checkbox to sort by. You should note that if you don't check this box and you do have headings in your data, they will be sorted along with everything else. This will allow you to select the Sort By columns by the column header rather than the column letter. You can then choose from the Sort On options. You can then select the sorting order. Finally, you can add additional levels of sorting to further refine the order of your data. In this example, we can click Add Level and then further sort based on the Q1 sales revenue from largest to smallest. You can now see that the data is sorted by region and each region is then sorted by the sales values. Filtering is a bit different. It allows you to customize data display based on criteria of your choosing. For example, Thomas from Westcal Publishing needs to show sales results only from representatives in the northern region. Sorting wasn't quite right for the task, but you could use a filter to do that. Now let's have a go at applying some filtering to better arrange our data. First, you need to enable filtering. Select a cell in the data you want to filter, then click Data and then Filter. This will add Auto Filter drop-down arrows to the top of each column. To view and use the Filter drop-down menu, click the arrow for the column you want to filter. You can choose to show or hide rows by clicking to select or deselect the checkboxes next to the list of regions that are available in the data, then clicking OK to apply your settings. You can also select rows to show by typing in the search field. Excel will automatically select data that includes the letter or string being typed. Have you noticed that by typing the letter A in the search field, the region Europe has been excluded? To apply the filter, click OK. All the rows of data with Europe as the region will be hidden. You should see that the row numbers turn blue and there is a double line in the row numbers indicating where the rows are hidden. If you save your file with a filter in place, the data will still be filtered when you reopen the file. The blue numbers are a key visual indicator when you open a file that you are not seeing all the rows. A small filter icon will also appear next to the filter drop-down arrow in the region column, indicating that there is a filter applied to that column. Next, let's explore the Text Filters submenu. Clicking one of the commands in this submenu will open the Custom Auto Filter dialog box, pre-populated with the selected operator. You can then enter the criteria required. Let's choose Contains from the Text Filters menu. The Custom Auto Filter dialog box will open. Notice that you can still click the first drop-down menu to choose a different operator other than Contains. However, since this is the correct operator, we will just type Asia into the text field and click OK to create the filter. We now see that only the data from the Asia region is displayed. There are two ways to clear a filter and display all data once again. You can click the Auto Filter arrow and click Clear Filter from Region, or place your cursor in the filtered column and click the Data tab and then Clear. With either command, the filter will be cleared and all data will be displayed. A key benefit to adding range names to your workbook is to ensure that formulas and calculations are easier to read and understand, especially if you are sending a workbook to a client or colleague. Thomas from Westcal Publishing needs to be able to work with large amounts of data, formulas and functions within a single document. While cell references can be used to identify where formulas are getting information to calculate data, it is not always obvious, especially to others who may be encountering the document for the first time. Thomas is aware that Excel allows you to give names to individual cells and cell ranges and then use those names in formulas and functions. Thomas wants to learn how to utilize this feature so that he can organize the worksheets efficiently and clearly so that his managers and colleagues can understand at a glance what data is being used in a formula or function. Let's look at one way to do this using cell and range names. Range names are meaningful labels that you can assign to individual cells or cell ranges. You can use a range name anywhere you would use a cell reference or cell range reference. This means you can use a name such as employees to describe a range of cells rather than their cell references. Range names make formulas much more readable, improve worksheet clarity, and greatly improve worksheet organization. Range names can even help in the overall design of your worksheet. On screen, cells A2 and B2 have been given names total sales and total expenses, and those names have been used in a formula in cell C2. As an added bonus, range names are absolute references. This means that if you copy a formula or use autofill while using named ranges, the formula will maintain its original cell references. Most small worksheets are usually constructed by filling a sheet with data and then performing calculations. However, range names enable you to create a worksheet by doing the opposite, constructing formulas and then adding the data. When you are designing your worksheet, you can create formulas using names instead of traditional cell references and then define the names for the corresponding ranges as data becomes available. Keep in mind when choosing cell or range names that all names must start with a letter, underscore or backslash. Beyond the first character, you can add any letter or number you wish. Additionally, names cannot contain any spaces, nor can they contain cell references. Finally, it is important to know that cell and range names are not case sensitive. Let's take a look at how defining and naming ranges of data works in Excel. On screen now is an empty worksheet with a defined formula, but no defined names, which results in a name error. This error will remain visible until both value 1 and value 2 have been defined. Let's add some range names using the name box. To apply a cell name or range name, first use your cursor to select the cells that you want to name. Next, type the name that you would like to use into the name box. Pressing Enter will apply this name. From then on, you'll be able to select this range by clicking the Name Box drop-down menu and then clicking on the range name that you set. Finally, let's look at adding range names using the New Name dialog box. Cells and cell ranges can also be named using the New Name dialog box. While this technique takes a little bit longer, you have more control over what cells the name refers to. To open the New Name dialog box, click the Formula tab and then Define Name. When the New Name dialog box is displayed, you will see that the name field appears at the top. The Scope drop-down menu allows you to choose if this new name will be applied to only the current worksheet or the entire workbook. Inside the Comment text area, you can enter a brief description of the named cell or range. By default, the cells that were selected when the Define Name command was clicked will already be filled into the Refers To field. If you wish, you can change this selection by clicking on the cell selector. Once you enter your options and click OK, the named range will be created. You can see a list of all the names that have been created by going to the Formula tab and clicking Name Manager to open the Name Manager dialog box. Clicking the New button will open the New Name dialog box, which you can use to create a new range name. If you select a name from the list in the Name Manager dialog box and then click the Edit button, the Edit Name dialog box will be shown. This dialog box is identical to the New Name dialog box. The only difference is that it will be pre-populated with information from the selected range name. To delete a range name, click to select the range name in question and then click the Delete button. A dialog box will then open to ask you to confirm this action. Click OK to complete the deletion process. Finally, the Filter command is used to show only certain ranges based on specified criteria. This is particularly useful when working with a workbook that contains a large amount of range names, as you can quickly narrow down the list to only those ranges that you would like to work with. Cell and range names are not just useful in keeping your workbooks more organized. They can also help immensely in the creation of formulas. This is because after you've defined a cell or range name, you are able to use that name in place of the usual cell reference. This makes formulas much more readable. Let's take a look at how to use range names in formulas in your Excel workbook. In this example, you can clearly and quickly see what this formula does. If it used standard cell references, it would be more difficult to understand. Perhaps one of the easiest methods to enter cell and range names into a formula is to use the formula autocomplete feature. In the same way the autocomplete feature suggests function names based on the first few characters that you type into the formula bar, it will also suggest cell and range names in a small menu. Double-clicking on a suggestion in this menu will insert it into the formula. You can differentiate names from functions and other objects suggested by the small tag icon that appears by each name. In addition to manually entering cell and range names, you can also utilize the useInFormula command to insert existing cells and range names into formulas. To access this command, click the Formulas tab and then useInFormula. This action will display a drop-down menu listing all of the existing cell and range names. Clicking on an option will insert its reference into the formula bar. Functions are an extremely versatile and useful feature in Excel. Pre-built and easy to apply, the benefits of this core component are endless. Excel has a vast range of specialized functions that can be used to perform complex operations on data for a variety of different purposes, including engineering, logic, and dates. Learning how to access Excel's extensive catalog of specialized functions, then identify and use the specific functions you require, will provide a strong foundation for you to develop your skills in Excel. So, how would you define what a function is? Well, Thomas from Westcal Publishing provided a definition of a function as a predefined formula that is available in Excel and performs a specific calculation based on specified values called arguments. While the basic functions in Excel cover the majority of use cases, there are some situations where a specialized function is more appropriate. Thomas understands that to be able to find and use specialized functions, you must be familiar with their syntax and understand how they work on a fundamental level. Let's have a look at the various functions categories and the syntax that should be used to make them work. Every built-in function that is available in Excel has been categorized in one of 12 standard categories. These categories are available on the Formulas tab, with some categories available under the More Functions drop-down menu. There are many types of functions within the available 12 categories, including Financial, which offers useful functions for working out financial information, or Date and Time, which is useful for project planning as it allows you to create calculations like how many days till a deadline, and Statistical, which contains a huge range of functions for statistical analysis tasks such as count. The count function is used to count cells that contain numbers. Count A is used to count any cell that contains data, and count blank only counts empty cells. Note that you can expand the number of standard categories using add-ons. For a more extensive list of function categories available in Excel and the type of tasks they can be used for, please look at the additional resources at the end of this lesson. To successfully use functions in Excel, you must first understand the required values for the function and the order in which they are used. Functions are a major part of what makes Excel so popular, so now you will explore some different types of functions and learn some tricks that you can use to perform complex calculations. Just keep in mind that even the most complex of formulas can be broken down into simple parts. While you're creating the formula, don't forget rules for formulas that we looked at in a previous lesson. Remember to pay attention to the order of precedence using the BEDMAS acronym and think about the number of parentheses you might need. Whenever you are entering a function, either in a cell or in the formula bar, Excel will display the function syntax in a screen tip and the current argument will be bold. Excel displays the syntax of a function by first stating the function, then in brackets listing the required arguments. Any argument enclosed in square brackets is optional, where all other arguments are required. Let's create an example. You've already used the sum function to total a block of numbers. But what if you only wanted to include figures from a particular area or a particular month? For that, you can use a variation on sum called SUMIF. You'll find that many of the standard functions have these kind of variations. The SUMIF function is used to calculate the sum of values in a specified range if they meet a specified criteria. For example, You could calculate total sales figures and only include numbers that are less than a specified value. In this formula, only values over 200,000 will be added together. The sum range argument is optional. You can use it if you want to add cells to the sum other than those specified in the argument. In this example, only numbers in the range K6 to K50 will be added together where they correspond with the text entry North America in the range B6 to B50. If you choose to leave out this argument, the function will only calculate the sum of the values from the previous range argument. So you've seen SUMIF used to add together numbers in a range that are under a certain value, and add together numbers in a range that correspond with a specified text value in a range. SUMIF can also be used to add together all numbers with a certain value that fall within a specified range. As you can see, these versatile functions can be used in a variety of ways. Another standard function that has this kind of variation is average if. The average if function will return the average of every cell within a range if the specified criteria are met. For example, if you want to calculate the average sale amount in a set range of sales data only for sales below a certain amount, you could use this function. In this formula, the average will be calculated for all values in the range below 200,000. The average range argument is optional. It can be used if you want to add cells to the sum other than those specified by the range argument. In this example, the average for the numbers in the range K6 to K50 will be calculated where they corresponded with the text entry of North America in the range B6 to B50. If you choose to leave out this argument, the function will only calculate the average of the values from the range argument. The COUNTIF function can be used in a very similar way to the SUMIF and AVERAGEIF functions that you have looked at. The COUNTIF function will count the number of cells in a specified range if the criteria are met. For example, the function shown here could be used to count the number of sales associates who have sold a certain number of products. Or you can use COUNTIF to compare values in two lists. The functions that have been covered so far all have an equivalent ifs function that allow you to perform those respective calculations on data that requires more than just one specified criteria. With a few exceptions, such functions have very similar syntax. While you become familiar with Excel functions, you may find it challenging to know which function to use in specific situations. In such cases, tools are available to help you identify an appropriate function for your purpose. One option is the Search for a Function feature in the Insert Function dialog box. As the Search for a Function text box suggests, type a brief description of what you want to do and then click Go. Excel will offer matching suggestions in the Select a Function list. Clicking a function will display the syntax and provide a brief description. You can also select a function category from the Or Select a Category drop-down list. This will display a list of available functions in that category in alphabetical order in the Select a Function list. Once you have selected the appropriate function, click OK to open the Function Arguments dialog box where you can define the required parameters. If you need support with using functions in Excel, you can use Help. Otherwise, there are some additional resources for you at the end of this lesson. Let's have a look at how to use specialized functions in Excel. Some situations require that a function be nested inside of another function. This means that you're using the results of the nested function as arguments. Using another function as one of the arguments in the formula expands what the original function can do. Here is an example of a nested function. The two sum functions have been nested inside of a single if function. The if function will often have other functions nested inside it. The if is a useful function as it tests to see if something is true or not and asks Excel to do different things based on the result. We'll be looking at this in more detail later. The way this example works is that if the sum of data in cells A1 to A5 is greater than 10, then this formula will sum the values of cells A6 to A10 and display that result instead. If the sum of data in cells A1 to A5 is less than 10, then 0 will be displayed instead. By default, Excel workbooks will calculate the results of formulas automatically. Occasionally, you may want to switch your workbook calculations to manual recalculation so that you have more control over when formulas are calculated. Typically, you would do this if you're working with a particularly large workbook and the response times in Excel are slowed when you change a value and numerous formulas calculate the results of this change at the same time. To change the calculation options, click the Formulas tab and then Calculate Options. This drop-down menu includes the automatic default, automatic except for data tables, and manual options. If you switch to the manual option, you can then calculate formulas in your workbook manually by clicking Calculate Now. Alternatively, you can also choose to calculate only those formulas on the current worksheet by clicking Calculate Sheet. To make creating and reviewing worksheets a bit easier, you can show the formulas instead of the results on the worksheet and the printed page. To do this, click the Formulas tab and then Show Formulas. This action shows formulas within the sheet instead of the calculated results. Now that you're familiar with Excel's more commonly used functions, you will learn about some of its more specialized ones. One of the benefits of Excel is that it can handle large amounts of data which can then be analyzed for business purposes. Text data can be prone to errors, mistyping or misspelling, for example. Or the text may not be laid out correctly to facilitate the analysis. Information that is imported from other sources may often need to be amended or tidied up. Excel offers a wide range of functions that can help you tidy up text data and prepare it for analysis. Thomas from Westcal Publishing has been asked to use text functions to import textual data from another workbook and format it so it meets the formatting requirements for the destination workbook. Text functions are used in Excel to analyze text-based worksheet data. While these functions can be used for data analysis, they are typically used instead to prepare data for analysis. Thomas is aware that text functions allow you to format textual data for use in other areas. Let's start by looking at functions that are specific to text analysis. The left and right functions are used to return a specific number of characters from either the left or the right side of a text string. Typically, these functions are used in situations where you need to transfer text to a destination where there is a limit on the number of characters each entry may have. The text argument is used to declare which text you would like to transfer, while the number of characters argument is used to declare how many characters you would like transferred. Suppose that cell A1 contains John Smith as a text string in a worksheet. Let's examine the possible examples of how the left and right functions would work with this data. As the number of characters argument was not set in this function, it will default to 1 character. This means that the output for this function would be H, the last letter on the far right of the text string. With the number of characters argument set to 5, this function will result in Smith as an output, the last 5 letters on the far right of the text string. With the number of characters argument set to 5, this function would result in John, including the space, as an output, the first 5 letters on the far left of the text string. This function would return only J as an output because the number of characters argument was not set. Similar in use and design to the left and right functions, the mid function returns characters from the middle of a text string. As with the left and right functions, the text argument is used to reference the cell with the text string in question or to enter a text string directly into the function surrounded by double quotation marks. The start number argument is unique to the mid function as it tells the function which character in the text string to start with. The number of characters argument then allows you to set the number of characters that you would like to return from the starting point that you set in the previous argument. Keep in mind that while the number of characters argument behaves the same as it does in the left and right functions, it's required in order for the mid function to operate correctly. Let's take a look at the possible examples of how the mid function would work with this text string. In this example, the text is contained within cell A1. The start number argument is set to 6, so the function starts 6 characters, including spaces, into the text string. The number of characters argument is set to 5, so the 5 characters from the starting position will be returned. This means that Smith would be the output for this formula. In this next example, the text is contained within cell A1. The start number function is set to 1, so the function starts at the beginning of the text string. The number of characters argument is set to 4, so the 4 characters after the starting position will be returned. This means that John would be the output for this formula. The len, short for length, function's sole purpose is to return the number of characters that appear within a text string. While there can be many uses for this function, it is typically used to check that text strings are of the correct length. For example, you could use this function to make sure that all of the text data within a row is under a specified length. The only argument in the text function is used to specify where the text data that you would like to count is stored. Suppose that A1 contains John Smith as a text string and B1 contains Jane Doe as a text string. Let's have a look at how the len function would work with this information in mind. In this example, the len function has the text argument set to A1. This means that a count of the text string within this cell will be returned. The output of this function would then be 10. In this next example, the len function has the text argument set to B1. This means that a count of the text string within this cell will be returned. The output of this function would then be 8. Now let's take a look at some more important text functions for trimming and changing the case of text values in data. The trim function is used to remove any empty spaces from text strings, excluding spaces between words. This function can be very useful in solving data compatibility issues. For example, a frequent problem in data entry is random spaces at the beginning or end of a text string. Such problems can greatly affect your ability to work with text-based data. Note that the only argument in this function text is used to specify where the text data that you would like to work with is stored. Suppose that A1 contains John Smith as a text string and B1 contains Jane as a text string. Let's have a look at possible examples of how the trim function would work. In this example, the trim function has the text argument set to A1. John Smith will be returned with all of the spaces at the beginning of this text string removed. In this second example, the trim function has the text argument set to B1. Jane will be returned with all of the spaces at the end of this text string removed. The upper, lower, and proper functions are used to change the case of the text in the data. The upper function converts all lowercase characters into uppercase, while the lower function will do the opposite. The proper function will only capitalize the first character of each word in a text string. For all of these functions, the only argument is text. This is used to indicate the text-based data that you would like this function to work with. Suppose that A1 contains John Smith as a text string and B1 contains Jane Smith as a text string. Let's examine some examples of how the upper, lower, and proper functions would work. In this example, the upper function converts all of the text within cell A1 to uppercase. In this example, the lower function converts all of the text within cell A1 to lowercase. In this example, the proper function ensures that only the first character in each word in cell B1 is capitalized. Let's take a look at two more specialized text functions for joining and transposing text to understand how they work and how they can be applied. The text join function allows you to combine or concatenate text strings together from multiple cells into a single cell. This function can save you an enormous amount of time if you need to combine data from multiple sources into one cell. The first argument, delimiter, allows you to specify what should be between the text strings when they've joined. This could be a space or another character or characters. When you are joining the contents of cells together, there is always the possibility that a cell might be empty. The second argument allows you to tell Excel what should happen in this case. There are only two possible entries here, true or false. If the word true is used, then text join will ignore any empty cells. This is the default setting. If you type false, Excel will include a space where the contents of the empty cell would have been. Finally, the text arguments allow you to define the text strings or range of strings that you want to join. Suppose that A1 contains John Smith as a text string, B1 is blank, and C1 contains Jane Doe as a text string. Let's look at some examples of how the text join functions would work. In this example, the text join function combines cell A1 with cell C1 and adds a comma and space between them, ignoring cell B1 because it is empty. Notice that the comma and space that we want Excel to put in as a delimiter is typed with double quotes around it. This is to tell Excel to reproduce this as a character. The output would be the two text values separated by a comma and a space. In the next example, the text join function combines cell A1 and C1 and adds a comma and a space, followed by another comma and space for cell B1 because the empty cell is not ignored this time. The output would be the two text values separated by a comma, a space, another comma, and another space. In this final example, because the delimiter argument is empty, the text join function combines cell A1 and C1, ignoring cell B1 because the ignore empty argument is true. The output would be the two text values joined without a delimiter. The transpose function shifts a vertical range of cells to a horizontal range or vice versa. To operate correctly, this function needs to be entered as an array formula in a range that has the same number of rows and columns. An array formula is different to a standard formula because it works with ranges or blocks of cells, not just with single cell references. Because of this, the keystrokes to confirm an array formula are slightly different, as you will see. For example, suppose that you wanted to transpose the values in column A so that they appear horizontally on row 1. To do this, first select the destination cells that you would like the results to be shown in. It is important that you leave these cells selected until you finish the function for the array formula to work correctly. Next, you would enter the transpose function into the formula bar with the original cell range as the argument. Press Ctrl, Shift and Enter to enter this function as an array formula, and the results will be displayed within the selected cells. You have had a chance to explore some commonly used text functions, their syntax and how they work. For a full list of functions, follow the link in the additional resources at the end of this lesson. Have you ever wondered what logical functions or logical operators are? Thomas at Westcal Publishing has been asked to use logical functions to check if the sales department met its weekly or quarterly goals, and if so, what the bonus would be for the team members. Thomas is aware that Excel contains a collection of logical functions that allow you to essentially ask yes or no questions related to your data. Such questions return a positive true or negative false response. Logical functions also allow you to perform calculations when certain conditions are met. Let's take a look at the logical functions that are available in Excel 365, including the AND, OR, and IF functions. Logical operators are used to compare two values against one another to see if they meet a specified logical condition. For example, should the values meet the logical condition 2 is greater than 1, then the output would be the logical value of true. If the values do not meet the logical condition 2 is less than 1, then the output would instead be false. Due to this behavior, logical operators are instrumental in constructing conditions for functions and calculations to run correctly. Excel provides 6 logical operators to compare numerical data stored in an Excel sheet. These logical operators are equal to, greater than, less than, greater than or equal to, less than or equal to, and not equal to. On screen, you can see a table with the logical operators that are available in Excel 365 and what they do. Let's take a closer look at the main logical functions and operators. The AND function returns a true value when all of the arguments are true. On the flip side, it returns a false value when any of the arguments in this function are false. For example, Thomas from Westcal Publishing could use this function to check whether the sales team have met all of their goals for the current quarter. While there can be a varied amount of use cases for this function, you would typically use it for conditional purposes. The first argument that is required in this function is logical 1. You can have up to 30 of these arguments in one AND function, with each argument separated by a comma. These arguments are where you enter the logical values and operators that you would like to test for, such as A1 is greater than B2. Additionally, you also have the option of entering a formula as a single argument. Let's take a look at some examples of how the AND function would work. Suppose that A1 contains the value of 15, while cell B1 holds the value 20, and C1 contains 25. While the value of A1 is less than the value of B1, B1 is actually less than C1. As not all of the arguments in the function are true, the AND function will output false. The value of A1 is less than B1, and similarly, the value of B1 is less than C1. As all of the arguments in this AND function have returned as true, the output for this function will be true. The value of D1 holds the logical value of false, so the output of this AND function would also be false. In this function, a simple equation has been added as an argument. As this equation is correct, the output from this AND function will be true. The OR function is similar to the AND function with one key difference. The OR function returns a true value if any of the arguments evaluate to true. With the same 30 arguments limit as the AND function, the OR function is constructed in the same manner and supports the same items. Typically, this function will be used to determine if there is a true value in a group of data. For example, Thomas could use it to quickly see if anyone in the sales department has made sales over a particular dollar amount in any one of the 4 months of this quarter. Suppose that A1 contains the value of 15, while cell B1 holds the value 20, and C1 contains 25. This OR function has 2 arguments and is checking whether either argument is true. A1 is less than B1 and C1 is less than B1. While the value of A1 is less than the value in B1, B1 is actually less than C1. Even though only one of the arguments in this function has returned as true, the OR function will still output true. In this second example, the OR function is checking whether the value of A1 is less than B1, and similarly, the value of B1 is less than C1. As all of the arguments in this OR function have returned as true, the output for this function will be true. In this third example, the OR function is checking whether the value in B1 is less than A1 or the value in C1 is less than B1. In this case, since none of the conditions have been met and they are all returning false, then the overall result of the OR formula would be false. The IF function is one of the most commonly used logical functions. It sets a cell value based upon whether a logical test resolves to be true or false. For example, Thomas could use this function to test if a salesperson at Westcal Publishing exceeded a sales goal. If that resolves to true, then this function could output a bonus amount. If it resolves to false, then this function could output a zero amount. The if function has three arguments: logical test, value if true, and value if false. The logical test argument is where you create the condition that you would like to test. The value if true argument will be the output of this function if the condition is found to be true. Similarly, the value if false argument will be the output if the condition is found to be false. Keep in mind that the value arguments in this function can hold both text and numerical data. However, all text data must be enclosed in double quotation marks. Let's look at some examples of how the if function works. Suppose that A1 contains the value of 15, while cell B1 holds the value 20, and C1 contains 25. In this example, A1 is in fact less than B1, so this function would output yes. In the next example, A1 is less than B1, so this function would output the result of the value if true argument, which is 500 in this case. In the final example, A1 is less than B1, so this function results in no as the output. The ifs function is an evolution of the if function that was introduced in Excel 2016. It is an alternative to using nested if functions, where you want to test multiple conditions and return multiple results based on those conditions. If you use the ifs function and then send your workbook to someone who has an incompatible previous version of Excel, the cell will show an error as the formula will not be understood. It is much easier to use and much easier to understand than a complex nested if function, and you should keep it in mind as you begin to use more complex logical analysis in your workbooks. The ifs function only has two required arguments: logical test 1 and value if true 1. Each argument is similar to those in the if function, but the benefits of the ifs function are realized when you begin to add additional arguments. The ifs function checks whether the first condition, logical test 1, is true, and if so, returns the value if true 1 argument. If the first condition is false, it moves to the next condition and performs the same analysis again, then continues through all of the logical tests. If none of the logical tests are true, the ifs function will return a not applicable value. You can prevent this outcome by making the last logical test in your ifs function true. Let's look at some examples of how the ifs function works. Suppose that A1 contains the value of 15, while cell B1 holds the value 20 and C1 contains 25. In this example, A1 is in fact less than B1, so the first logical test is false. In the second logical test, B1 is less than C1, therefore the function would output the contents of cell B1 20. In the next example, both of the logical tests are true. The function would output the string A1 because it returns the value if true of the first logical test that is true. In the final example, both the first and second logical tests resolve to false. The third logical test has been defined as true, so the function would output the contents of cell C1 25. You've had a chance to explore some commonly used logical functions, their syntax and how they work. For a full list of functions, follow the link in the additional resources at the end of this lesson. Over the course of these lessons, you've had a chance to work with formulas and functions in Excel. You learned that a formula is comprised of functions, arguments, calculations, and cell references. You explored different methods for constructing formulas and inserting functions in a worksheet. And you had the opportunity to start applying formulas and functions in a practical way. You learned about the difference between sorting and filtering and how both of these features can be applied to organize and arrange how data is displayed. You saw how sorting can be used to arrange data in a worksheet, for example in alphabetical, numerical, or date order. And how filtering can be used to refine the data in a worksheet so that only data within certain criteria is displayed. You explored what cell and range names are, why they're useful, and how to add range names to the data in your worksheet using the name box and the new name dialog box. And looked at how to edit and delete range names, as well as how to use cell and range names in formulas. You discovered that Excel also has a wide range of specialized functions that can be used to perform complex operations on data for a variety of different purposes. You explored some of the specialized function categories, the syntax that defines them, and how they can be applied to manipulate and control data. You learned how to use text functions with various operations to manage, refine, and extract text data. And looked at functions that enable you to trim, join, and transpose text values in a worksheet, as well as change the case of text. Finally, you learned how to use logical functions that apply conditional logic to produce a true or false result, which can be used to analyze and organize data. And examined the main logical functions and, or, and if, and explored some examples of how they can be used with data. So there you have it. You're on your way to mastering functions in Excel. Great work. And there's so much more for you to learn about Excel.
Thank you for watching our video. We hope you found it helpful. If you enjoyed this video, please hit the like button below and subscribe to our channel for more videos like this. If you know someone who could benefit from this information, please share it with them. We would love to hear your thoughts on this learning course, so please leave a comment below. Thanks again for watching, and we'll see you in the next video.